Hello, welcome to the Fundamentals of Artificial Neural Network. In this chapter, we are going to study one more case related to electrical engineering. In this problem, we are going to use artificial neural network to find and estimate the rotor position of the switch reluctance motor so that we can eliminate the position sensor. So let's first understand the problem. So those who belong to electrical engineering, they can easily understand the problem, and rest also can understand the case studies. So let's discuss it about. So problem statement is like that: we need to design the artificial neural network which can estimate the angular position of the switch reluctance motor. So reference paper is cited here. It is quite old, decade old, but it is good case study to understand the application of artificial neural network with the help of MATLAB. So what can we do in electrical engineering and also other branch, you can relate it. So let's understand the problem so we can go through more detail. So switch reluctance motor actually offers so many benefits over conventional induction motor, that is higher efficiency, better performance, that is starting torque and constant power region, and also eliminate the costly magnets. So obviously it will be the next choice for the electrical motor industries, but it must require the position sensor. It also simplifies the manufacturing process by reducing the steps in the manufacturing process. So this is one more advantage. But to run the switch reluctance motor, we must require position sensor which predicts the exact rotor position and switching the phase on off accordingly. So phase switching should be synchronized with the rotor position, so that position sensor is must. But position sensors increase the cost, size and weight of the motor. So there are several sensorless techniques have been developed in past to eliminate the position sensor from the switch reluctance motor. Today we are going to discuss such method, which is one of the most accurate sensorless method based on artificial neural network to eliminate the position sensor from the SRM drive or switch reluctance motor drive. So rotor position can be estimated if we know the actual data of magnetic characteristic of the motor. So if you not aware about the magnetic characteristic, let's discuss. It is the three-dimensional non-linear relation between flux, current and rotor angle. So there are three parameters: flux, current and rotor angle. We need to predict the rotor angle from the data of flux and current. If we have taken the example of 6x4 pole 60 kilowatt switch reluctance motor, here we are having the magnetic characteristics. So flux and current, and this is for the fixed rotor position, that means at fixed angle in unaligned condition. If you increase the current, because air gap is high, flux will increase linearly. In this position, if you reach up to this position and lock the rotor position in aligned position, then if you increase the current, flux will increase like this, and this is saturation region again. Now flux will increase very less with increase in higher current in this region, saturated region. So this is totally non-linear relation, and to find the rotor angle from the data of flux and current, we must require the lookup table or data, but instead we are going to use the artificial neural network to solve this problem. So if we have input, two inputs are required, flux and current. If we have this data, then output should be prediction of rotor angle. In practical implementation, flux can be calculated by integrating difference between voltage and voltage difference. That means data required are voltage and resistance of the phase winding. So because in the MATLAB simulation, this is already calculated within the model by providing the measuring terminal at the output, so we do not require to inculcate it. Because in the SRM model, flux is provided as the output from the measurement terminal, which is calculated with the same equation. So in simulation our input will be flux and current, else in actual there will be current sensor and voltage sensor. So when we are eliminating position sensor, we need current sensor and voltage sensor, which are less in cost and in size and all. So if we understand the three-dimensional characteristic, it will be look like this. Here we have the flux, we have the current and angle. So this is what three-dimensional relation is look like, and which type of problem we are going to map with the help of artificial neural network. So this is the problem to estimate the rotor angle from the data of flux and current.